Factor Fest, page 3. Page 3, and it jumps into high gear right now. This is the difference of squares. So remember, we can look at this as if this is x squared minus y squared, where x is going to be representing x squared minus 4, and y is going to be representing 9 squared, or y squared minus 9. And we are going to factor this. This looks a whole lot easier than this noise. So if we saw this, this would be x plus y, x minus y. I think everybody would agree with me that that's pretty good. So if we substitute them back in, instead of writing x, we write x squared minus 4. And instead of writing, and we can write plus my y value, which is y squared minus 9. And then we would write the x value, which is x squared minus 4, minus the y value. And this is where it gets tricky. That was the tricky part, because we're minusing the y, and that's the opposite of that. So we have to, we're going to write this left side, x squared plus y squared. These are like terms, so that's minus 13. Good. And then we're going to distribute that negative. So this becomes x squared minus 4 minus y squared plus 9. So x squared plus y squared minus 13, and then x squared minus y squared, and these like terms make plus 5. So that should be my answer. Standard form, we're good. I like that one. Okay, now we get into the tricky part where when we take the square root of both of these numbers, square root gives me x squared minus 25. Square root of 625 is 25, and you get x squared plus 25. Most students would stop there. They think, oh, difference of squares, I did it. But did you notice that you have another difference of squares here? So this is x minus 5, x plus 5. And then this one cannot be factored. There is not the addition of squares like cubes. That's coming later on in this section. So that would be my final answer, or final factor. Same thing again. And this is typically a telltale sign when we see something to the fourth. We know, oh, they're trying to trick me. And then p squared minus 9 is a difference of squares. That's p minus 3, p plus 3, p squared plus 9 cannot be factored. So these should be relatively simple and easy. This isn't too bad. I think it's just taking the square root of these terms. Square root of 36 is easy. That's 6. Square root of x to the 6th is x to the 3rd. Square root of y to the 4th is y squared. Minus square root of 81 is 9. Square root of x to the 4th is x squared. Square root of y to the 6th is y to the 3rd. And then we do its conjugate, 6x to the 3rd y squared plus 9x squared y cubed. Those cannot be factored. These are not. Oh, did I tell you, right? In video 2, what did I tell you? I was like, oh, there is a common factor. There was a common factor. See, I would have to do the common factor, and students don't always see that. Look at all these common factors. Yikes. There's a whole ton of common factors. This is a really bad start. So I'm going to erase this, and I'm going to start back from new, because going from that point would create so much more work. So I'm going to do a common factor. And my common factor is actually going to be a 9. let's look at my x's. I can take out x to the fourth, and I can take out y to the fourth. So if I take that out, I get 4x squared minus 9y squared. Oh my goodness, how much easier was that? And this is conjugates, 2x minus 3y, 2x plus 3y. What a terrible mistake. But that just shows even a teacher who's been doing it for 30 years can make a silly mistake. But the important thing was I didn't just blow through it. I actually noticed my spidey senses saw and said, whoa, 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 I made a mistake here. Let's slow down and let's go back and fix it. So that's good. Which of the following is the correct factorization of x to the fourth? So minus 1, we see we have x squared minus 1, x squared plus 1, and this is still a difference of squares. So a lot of students would just leave and say, oh, hi, you thought that was the answer. That is wrong, because this can still be factored. This is difference of squared. So that makes x minus 1, x plus 1, and x squared plus 1. So which one of those is that answer? The correct answer is actually B. Yes. Here we go. I would advise you to substitute and write x squared minus b squared. Substitute, instead of writing a plus 1 quantity squared, I would write x. And so we know that we're going to have x minus b, x plus b. Doesn't that seem super easy? And instead of x, now we're going to replace it back in for each of the x's. Wherever we see an x, we are going to replace it with a plus 1. So you have a plus 1 minus b, and you have a plus 1 plus b. Now I wouldn't leave it like that, but does that give me multiple choice? It does. So what am I? A plus 1 minus b. So I think it's D. Now Mr. Mac would rewrite it. I would have written it as a minus b plus 1 and a plus b plus 1. That's how I would have written my answer. But that's the multiple choice. Gave me that and their equivalent. All right, cubes. So the difference of cubes, much like the difference of squares, let's start a page. So just like the difference of squares has a template that it's a minus b, a plus b, and even when you get complicated, we can just substitute things. Well, we have these cubes. So you can have a cubed plus b cubed, and you can also have the difference of cubes. So different from difference of squares, there was no, this is difference of squares. You don't have the sum of squares. So there's only the difference of squares. But with cubes, you do have the sum of cubes and the difference of cubes. So this is going to work into this template, a plus b times the quantity a squared minus ab plus b squared. So that's what that produces. And the difference of squares produces a minus b times the quantity a squared plus ab plus b squared. So these are similar and different in very specific ways. That sign's always going to be that sign, and this is always going to be the opposite of that sign. And we'll see it again. This sign will always be this sign, and this sign will always be the opposite of that. And we notice that we get this is always going to be the same, and those are going to be always going to be the same. So we're going to use that template quite a bit throughout these problems. So I'm going to write it, and then I'm going to show, so a cubed minus b cubed. So what is my base? The base being cubed. What is the base being cubed? Well, x is being cubed, and then can I write 27 as a cube? Yes, as a 3 cubed. So we really see this as x cubed minus 3 cubed. So I know my a is x and my b is 3. So remember, I get a minus b times the quantity a squared plus ab plus b squared. So now I'm going to take my a. So in this case, a is x, b is 3, and I'm going to substitute those in. So if I substitute, I get x minus 3 times the quantity x squared plus a is x times 3 plus 3 squared. And I can simplify that. So that'll be x minus 3 times the quantity x squared plus 3x plus 9. Oh yeah, if you can get that down, and we're going to notice it's going to be real fast how we're going to make these solutions, because it should be fast. It's really not that difficult. They run into the same situation, and as long as you can see what that base of each cubed, I may have said squared before, cube, that's good. Now this is not in standard form, so I'm going to rewrite this. And now this is not the differences of cubes, and we have a first term negative, so I'm going to factor out a -1. And now it turns back into the difference of cubes. So this is b cubed minus 2 cubed, that base. So if I have a cubed minus b cubed, I have a minus b, a squared plus ab plus b squared, where my a is going to be b, I know that's confusing, and my b is going to be 2. So I'm going to plug those values back into this template. So if a is b, and we got that negative outside there also, don't forget the negative, that's going to be minus my b value, which is 2. And then we have a, which is b squared, plus a times b. Well, we're just going to multiply these two together, which makes 2b. And then we're going to square b, which is 4. So that's not hard. It's actually really nice, easy, and you should be becoming proficient at it. So that is 5x cubed, 5 cubed, x cubed minus 3 cubed is how I can see that. My a is going to be 5x, and my b is, and I can write that as 5x cubed minus 3 cubed. So my b is going to be 3. So I have a cubed minus b cubed, which produces a minus b, and produces a squared plus ab plus b squared. So let's plug those values. Let's plug these values back in. 5x minus 3, and we get 5x quantity squared plus 5x times 3 is 15x, and then b squared is 3 squared. So we get 5x minus 3 times the quantity 25x squared plus 15x plus 9. And square root is 5, square root is 3, 15 not doubled. So I checked to see if this was a binomial square. This would need to be 30, because we do the square root of 25, which is 5x, square root of 9, which is 3. 5 times 3 is 15x, but we have to double it. So that's tricky. Some students might think that that is a binomial square. That does not produce 5x plus 3 quantity squared, because that would be 25x squared plus 30x plus 9. So a little tricky, but got the spidey senses up. Good. Let's do 48. So we can rewrite that as 2 cubed a cubed minus 3 cubed b cubed. You like? And we can write that as 2a quantity cubed minus 3b quantity cubed. So I know that my a is 2a, my b is 3b, and this is the difference of cubes. So a cubed minus b cubed produces this template, a minus b, a squared plus ab plus b squared. So my a is 2a minus 3b times the quantity. 2a squared is 4a squared. Let's multiply. 2a times 3b is 6ab. And then 3b squared is 9b squared. Oh yeah. If you did that problem that fast, you are pretty good. 27, y to the 9th, 125, z to the 6th. So 27 can be written as 3 cubed. Y to the 9th is y cubed. No. Y to the 3rd. Oh. Y to the 3rd cubed. Whoa. Look at that little trickiness. That is 5 cubed, and that's z squared to the 3rd. Because power of a power, we multiply. 3 times 3 is 9. 2 times 3 is 6. So I need so my base is going to be 3y cubed to the 3rd. Oh, this is plus. So, okay, but we still want to shoot for this, and that's going to be 5z squared. Is that the first cube? Did we do pluses or minuses? Oh, those were all minuses up until that point. 5z squared cubed. So, when you have a cubed plus b cubed, that's the sum of cubes, you're going to get a plus b times the quantity a squared minus ab plus b squared. So this is the sign that changes. Everything else is going to be the same. So my a is 3y cubed. My b is going to be 5z squared. So let's plug those in. A is 3y cubed plus b, which is 5z squared, times the quantity. I'm going to run out of space. Let's move you over a little bit. A squared is going to be 9y to the 6th minus a times b, which is 15y cubed z squared, and then 5z squared, quantity squared, is plus 25z to the 4th. Oh, that's nice also. These are getting good. These are getting good. Let's make sure I did it right. I'm pretty sure. Yep, that's good. Okay, this can be written as x squared cubed. This can be written as y cubed cubed. And that can be written as x squared y cubed cubed plus 64 is 4 cubed. A cubed is a cubed, and c to the 6th is c squared cubed. So we would write that as 4a c squared quantity cubed. Yep, those are the bases of each of those. That's good. And then we have a squared plus, not squared, cubed, b cubed, which produces a plus b, a squared minus ab plus b squared, where my a value is x squared y cubed, and my b value is 4ac cubed, squared. All right, so a plus b. A is x squared y cubed plus 4ac squared. I gotta move it over again. Run out of space really quick in this when we're working these big problems. So a squared is going to be x squared y cubed times x squared y cubed, which is x to the 4th y to the 6th, minus, we're going to multiply x squared y cubed times 4ac squared, which is negative 4ac squared x squared y cubed. And then we're going to square 4ac squared quantity, which is 16a squared c to the 4th. Yep. See, what would we call it? Squares, cubes, cubed, subtracted. The difference of cubes and the sum of cubes actually really isn't that hard. So let's break 8 into 2 to the 3rd, a to the 3rd, b to the 3rd, to the 3rd. Oh, we went back to minus. Were we at minus? No, we were at plus. Minus. This is going to be 4 to the 3rd. This is going to be x to the 3rd to, oh, no, x to the 4th to the 3rd. And this is going to be y to the 2nd to the 3rd. So we would write that as 2ab cubed to the 3rd minus 4x to the 4th y squared to the 3rd. Those are my bases. And that helps me when I have my a cubed minus b cubed as my template. And you have a minus b and a squared plus ab plus b squared. So that's going to be 2ab cubed minus 4x to the 4th y squared times 2ab cubed is 4a squared b to the 6th plus 8. I'm again going to run out of space really fast. Plus 4 times 2 is 8. ab cubed x to the 4th y squared, and then that's going to be plus 16 x to the 8th y to the 4th. Yes. Oh, I made a mistake on the other one. There you go. Oh, shoot. Okay. Well, it's not that I made a mistake. I did make a mistake because there is a common coefficient. So let's erase all this work and let's do it a little bit easier. So we can see that there is an 8 that is a common factor. That gives us a cubed b to the 9th minus 8x to the 12th y to the 6th. And now we can rewrite. We can write that as a to the 3rd, b to the 3rd to the 3rd minus 2 to the 3rd times x to the 4th to the 3rd times y to the 2nd to the 3rd. Now we can rewrite that as 8, and that is going to be, well, let's do braces. So a to the 3rd, no, a, b to the 3rd to the 3rd minus the quantity 2 x to the 4th y squared to the 3rd. And so my a value is going to be ab cubed. My b value is 2x to the 4th y squared. That's just for our purposes, substitution purposes. Whoa. So we get 8. Now we're going to get a minus b. So a is ab cubed minus b is 2x to the fourth y squared. And then we get a squared, which is a squared b to the sixth, plus the product of these two, which is 2ab cubed x to the fourth y squared. And then we're going to square my b, which is plus 4x to the eighth y to the fourth. That should be the correct answer. Yep. We're good. All right. Oh, this is nice. So we've already got our base figured out on the left side. And then 216 is, what's that, 6? 6 cubed. So my a is going to be r plus 6. My b is going to be 6. We're subtracting. So we're going to have r plus 6 minus 6. And then we're going to have, oh baby, r plus 6 quantity squared. Remember, it is a minus b, a squared plus ab plus b squared. So I got to square my a value. So when I square that, that's the quantity of r plus 6 squared. And then a times b is going to be 6 times the quantity r plus 6, which is 6r plus 36. So that's the AB part. That's what that is, A times B. I multiplied these two together. And then I'm going to square B squared, which is 6, which is another 36. Okay, that's good. And now let's do, well, we can simplify that. That's R. That's nice. This is a binomial square. That's r squared plus 12r plus 36. I should be able to do it that fast. Plus 6r, and that's going to be plus 72. Now let's continue to simplify. We have r squared, we have 12r and 6r, which is 18r, and we have 36 and 72, which is 108. Ooh, that's nice and clean. Yeah, that's nice. Okay. So hopefully that technique of substitution is making this a little bit easier. So we got x plus 3 quantity cubed minus 3 quantity cubed. My a is going to be x plus 3. My b is going to be 3. I got a minus b. And then I have a squared. And then I have plus a times b, which is 3x plus 9. And then b squared, which is 9 again. So these are going to cancel again. We're left with x on the outside. That's x squared plus 6x plus 9 plus 3x plus 18. And x times the quantity x squared plus 9x plus 27. Again, very nice and elegant solution. I like those. Last one, 54. So this is 5 cubed minus 4x minus y quantity cubed. Now this is going to get tricky because of that negative and that quantity. So a is going to be 5, b is going to be 4x minus y. So when we have a minus b, we have to do minus 4x minus y. That's a quantity. And then this is going to be a squared, which is 5 squared. And then it's going to be plus a times b, which is going to be 5 times 4x is 20x, and 5 times negative y is negative 5y. And then we have b squared, so that's this quantity squared. So plus the quantity 4x minus y quantity squared. So let's do some simplification. So we have 5 minus 4x plus y. 5 squared is 25. plus 20x minus 5y. And now let's do 4x minus y quantity squared. That's going to be 16x squared. Let's do 4x times negative y and double it. So that's negative 8xy. And negative y squared is positive y squared. Let's write it in standard form, negative 4x plus y plus 5. And let's write this. That's going to be 16x squared. Plus, nope. Oh, that's good. Question, what comes first? I'm going to do I'm going to do minus 8xy. And then I'm going to do plus 20x. So I've done this, I've done that. Then comes y squared, alphabetical, then negative 5y, and then plus 25. There are no like terms there at all. And then you have this first term negative, so I'm technically going to factor that out and get this. And then 16x squared minus 8xy plus 20x plus y squared minus 5y plus 25. Wow. And there's some fun stuff. Later on, you'll kind of learn to look to see if we can factor that. But we're going to keep it we're going to keep it on the down low and just keep it here and assume that this is the right answer. All right, that was page 3. That was faster. We're getting faster. Less explanation because these are things that you should know at this stage. So, good.